Remember, you guys are supposed to have tables in your homework. And you could have said some different wording. Instead of this, you could have also put.
It's so weird. It's like you write it
Yeah,
off
right?
and it.
I don't know. Every day comes.
It's Friday. So weird.
You could have said concave down. What are some other words you guys use instead of vertical translation?
Shift down.
Shift down.
Wider.
Wait. It wouldn't be narrower and wider.
Wider.
Actually, neither.
Oh, no, it's neither.
Why is there no vertical stretch? You need to focus up here. Why is there no vertical stretch? Yeah, the only number in front's a 1, right? There's not a 2, there's not a 1/2, so not narrower or wider. No vertical stretch or shrink. It's only concave down, which they said reflection. Shift down 7 or vertical translation 7 units down. This one, you would have said vertical stretch, or you could have said narrower. It's also concave down. And guys, the order doesn't matter, just whether or not you're able to pick out the characteristics. This wording is okay, but the simpler wording is good too. And a shift where? Up 1. Up 1. Couple more seconds. Josh, do you have a question? What was
Yeah,
it?
it's not really something I should.
Okay. I'll ask in a second. Jay, thanks for letting me know I'm not good.
Alright, let's not look at it.
To prove that it was done today, then bring it in on. That's okay. Just don't forget, maybe you can put a reminder in your phone real quick right now since you're not sure. Alright, let's go ahead and scroll down because you guys have a couple more evens, I think, right?
Yeah,
Alright.
24 and 44. I just need to see.
Oh, they're at the bottom. You guys see them? 24 should be 3 and -3, and 44 should be positive 7/9.
Hey, I did it already. Is this 42 or 43?
Remember the odds are in the back of the book. So this is 44 because you guys had
No, but
43.
The homework?
Oh, this is homework number 42.
Come on, guys.
All right, do we have any questions on homework from last night? Josh, what do we got?
43.
43, anything else?
44.
Okay, so the last two. Any others besides 43 and 44?
I guess 10.
10?
44.
Okay. All right. Remember, kiddos, we're going to do homework questions in just a little bit. So right now, notes open.
Notes open.
Right now, notes open. Everybody all together. We're doing homework questions in a little bit, so we're not passing up homework yet. Diego, real fast. What's up, bud? Go fast. Next time it'll be a tardy. Gotta go fast and remember things, okay? Now, kiddos, 4 notes. I'm going to show you guys what I want you to write down. No warm-up to start today. You could have done one, but it would have been kind of hard.
Too hard.
No, not too hard. It's a better warm-up for tomorrow. Okay, Angel, notes open. I want you guys to skip a line right here. Can you see that? Probably not so good. I want you to skip a line where I put a little bracket, skip a line right there. I also want you to skip a line right there. But otherwise, why don't you write, sorry Diego. Next time, Diego, just carefully go behind. So skip a line in between where you see a space and skip a line in between where you see a space. Let me give you a couple moments to get notes all ready to go.
Let's say, like, if we run out of space in the book, and we're in the middle of a lesson, we start a new
Yeah, just
book.
start a new one, and for the note check, just be bringing both until we can check both. Good job, bud.
What do you want me to tell you?
I was going to get it in just a second. You want to step in the hallway? Or is it right here? You step in.
Yeah.
All right, kiddos. Write down your notes. I'm back here.
Someone's salty. Oh my gosh, no, man,
I actually got to understand this.
Mom. 11.
I understand what you're saying. I don't know why. He's not people on the back of the
Joshua, you can comment. Thanks for giving me a heads up.
Yes, it's great. Sleepy presentation. I can watch the homework and do it.
Josh, make sure you write down.
Okay, can I take a picture right now?
For that little gap, is it one line review?
Just one
No,
line.
no.
Just one line should be enough. Alright, I'm checking notes. You should be right word for word. You should be about halfway there.
Don't see my chance, you can.
State. State championships. FYOB.
Hopefully we can even do like last time things.
I'll be doing that one.
Alright, Alan, Caleb, the missing notes should be all filled out. Nice. Is Alan's all filled out?
What's on the board?
Honestly, you never know what you're doing. It's a new section, but.
Oh, I didn't know. I didn't know.
Every time you see red at the top, new section, okay?
Okay.
There you go. And Josh is getting it. Alright, now since yesterday we introduced a lot of stuff, I was kind of forgiving people back today though. Remember A's and B's on the last test, when I say to separate, if you want to, you can go in the back to work on homework. As long as you're earning it. So I'm gonna be keeping an eye open today that you guys are following along the notes, that you have the homework ready. We're gonna do homework questions right before I say to break up. So if you don't have any homework questions, when we start to do them, you just move automatically to the back. If you do have homework questions, wait and make sure you get them answered. Then you can just give your homework to me and then like that. But it's an option. So once again, some of you are like, no, I wanna stay up here and keep learning, and that's okay, awesome. Okay, so did this end in order to help us out just a little bit? Dylan's been gone a couple days, huh?
Yeah.
He's sick.
Same with Jackson.
Rob, I'm gonna have you, just because remember people move to the back now, I'm gonna have you come on up and sit next to, well, that's usually Dylan's seat, so I don't wanna fill Dylan's seat. But we have a couple empty seats over here. So let me go ahead and have, Tyler, you're gonna come up to this front seat right here next to John, and then Ron, you're gonna come up next to Jay, okay? So why don't you guys go ahead and move right now? Why don't you guys go ahead and move right now?
We're the back.
Man, it's still not starting. Alright, Tyler, grab a seat quick. Thank you. And then Rob, grab a seat quick. Alright, kiddos, my iPad's dying for some reason. It just doesn't charge no matter how I try to plug it in.
Wow.
So I'm just gonna work on the smart board today. I need you guys to really work to try to focus, okay? Alright, kiddos. Here we go. What is different about this function up here on the board that's circled in yellow? What's new? What's added?
Another
No. The C was there before, the A was there before. If you look at yesterday's notes, didn't we talk about A? What do we know from A alone?
It's always squared.
A is always next to the x squared, that's good. But what does it tell us? Yeah, if A is bigger than 1, that's going to widen, vertical shrink.
And the front is smile.
Okay, hold on. Too many answers at once, but thank you for all the participation. Jack, focus up here. Okay, here we go. So A, the bigger A is, the narrower the parabola becomes, because we're stretching it, right? So the bigger A gets, the narrower my parabola goes. And then the smaller A gets, like 1/3, 1/4, 1/10. What's happening to my parabola? It's getting wider. Okay? What else does A tell us about?
Smile or frown.
Smile or frown based on what part of A? Not the number part, but the negative or positive, right? So let's remind ourselves real quick right here. If A is less than 0, if A is negative, a little double-sided arrow, I can do a single arrow. In higher math, single arrow means something special, but not right now. If A is less than 0, what kind of concavity? Concave down like a frown. And if A is greater than 0, Angel, try to keep it quiet next time.
Up.
Concave up like a cup. Okay. We've talked about A. It's no big deal. Question, what else do we know about?
Oh,
The C. Yesterday we talked about the C. And the C, if the C is positive, where are we shifting? We're shifting or translating up. If C is negative, then we're shifting or translating down. This is what's new.
Adding
the X.
The BX is new. Okay? So we had a whole homework, actually a couple, with just AX squared. Then we had a whole homework, actually two, with AX squared plus C. Now we have section 8.3, which says let's introduce something else.
So does that make
BX.
bigger?
Kind of. Now the nice thing is, in tonight's homework, there's no chart, no graphs.
Yay!
That's nice. There might be graphs in the question, but no making graphs. That's going to be saved for tomorrow because it's going to be harder with this extra piece. But we do still have some things to learn. Tyler, put up. Come on. Thank you. Now, we need to learn about a y-intercept, axis of symmetry, and vertex. Now, we've talked about all three of them, but we need to fill in some new information now that there's a b. So, y-intercept. Do you guys remember? Well, let's not even ask that. What have I made right here that we're trying to fill into? What is it when we have parentheses and a comma?
The x-axis and y.
Yeah, kind of. An x point and a y point. So we're trying to figure out the x coordinate and a y coordinate for a point. Now, what have I already filled in? X is 0. So can't I take an equation and can't I say, what's f of x a snazzy name for the y value?
The Y.
Can't I try plugging in 0? What happens if I plug in when x is 0? Yeah, I know. I don't know what's going on. What happens when you square 0?
Everything is
Still 0. And when you multiply something by 0, what's this whole piece going to become?
0.
0.
Oh.
What's b times 0?
0.
C is still there. So what does y equal if x is 0?
C.
Good. Guys, fill in your blank. The y-intercept is going to be, for any parabola, is going to be 0, comma, c. So this shows us that shift up or shift down, because the c is going to send the parabola up or send the parabola down from where it normally is, which is 0, 0.
Where would C be on a graph though? Let's say if you're on a graph.
I actually have an example on the next page, so let's go ahead and wait. But I'll try to show you, okay? Now, axis of symmetry. We talked about it a little bit, and I didn't really label it. Axis of symmetry, I want you guys to show me, right here in this line that you skipped, show me a couple parabolas. Just general ones, no specific tables or points. Show me one concave up one and one concave down one. Parabolas have symmetries very similar to butterflies. Why am I saying that? Butterflies have two wings, and don't they generally look the same on both sides?
Yeah.
And when they
Mostly.
are flying, what happens when they put their wings together?
Clap together.
Looks like the same, right? So, question. There is a line about which, in a butterfly, they like the middle like its body, right? There's a line, and the butterfly is the body, and the wings kind of are the same on either side, right? In a parabola, the axis of symmetry is the fold line. The place that you could fold it, and it should be the same on either side. How many of you guys have ever made or tried to cut out hearts, like from scratch? Come on, in elementary school, most of you guys had to make Valentine's for the class, right? Okay. If you're just trying to cut out a heart, how hard is it to make it perfectly to where it'll match both sides?
Very hard.
It's hard.
Not possible.
But what's the trick?
You
Fold the paper
and I
and cut out one side. Same thing here. How could you fold, or where would you fold the parabola, Aiden and Ian? In the middle. This middle is the axis of symmetry, where you could fold it. Oh my goodness, where you could fold it and it would match. Yeah, I don't know what's going on.
Oh,
now it works.
oh wait, never mind.
There we go. Where you could fold it, that's the axis of symmetry. Now guys, if you remember, and maybe you don't, from a long time ago last semester, we talked about vertical, actually Coach Trapp talked about vertical lines. And the vertical lines always have an equation of x equals a number. And there's a very special number of any quadratic of this form that x will always equal to get us this fold line. And it's going to be negative b all over 2a. Now some of you, maybe that kind of fraction will confuse you, so let me show it a little bit better. Negative b all over 2 times a.
Yes.
Let me grab out a highlighter real quick just so we can go ahead and make sure we see the important parts that we've learned so far. So we have, you guys are writing down word for word.
Sorry, that's a B, right?
Yes.
Uh-huh. So far we have the y-intercept being the point 0c. We have the axis of symmetry being the vertical line where we would fold around,
How's that so straight?
being negative b over 2a. It actually compensates, and so when I try to do a straight line, it fixes it and makes it actually straight when I use a certain tool.
I'm about to say, I was like, shoot.
I know, right? That's not me. It'd be like, if it was me. Okay, one more, vertex. One more, vertex. Jenny, up here. Okay, for the vertex, we've seen the vertex in parabolas. Axis of symmetry is the line that we would fold on like a heart if we were trying to make it. The vertex, that's a point. Now, for like ax squared, it usually is the point 0, 0. But if we start shifting, maybe it's going to be a different point like 0c. But here's the problem, kiddos. When we introduce, Diego, go ahead and put it down, Sally, to that focus. Thank you so much. Eyes up to the front, everyone. But when we have ax squared plus bx plus c, we're not just shifting up and down anymore. We might be shifting right and left. The math is a little too hard to show you how that works until chapter 9, then we'll take some time on the algebra. But this can shift all over the place now. So instead of knowing that it's always at 0, 0, we won't know it's always at 0, 0, because it won't be. Instead of knowing it's always at the y-intercept, it won't be. It could be moved somewhere else. So here's the way to find it. We take this special x. Wait, do you guys see how the axis always goes through the vertex?
Oh yeah.
The vertex is in the middle. The axis is the middle. They're going to be in the same x position. They're going to have the exact same x value. The nice thing is then we only have, okay, let's keep our focus things to ourselves so we're distracting someone else. Ours are really cool. Let's make sure they're staying still. And then the spinning things, I don't mind you guys having them as long as you're focused. But if you're distracting, I have to outlaw all of them for this week. It'd be a bummer. But it is how it is. If you're distracting other people with them,
That's so weird.
what do you think? I don't know. How's it going? Anyway. Yeah, right? They're supposed to help you focus. If they're not helping you focus, then I'll outlaw them.
I use them for 2 reasons.
Come back.
Wrong class.
Come back. So we have x equals negative b all over 2a. However, I just told you a vertex is a point, and so a vertex needs an x and a y. Turn this to your notes real quick. Make sure it's all in everything. So we solve for x using the formula, and then we solve for y by plugging into the function. Okay, let's go ahead and highlight that one too. If you guys have highlighters, now's a great time. Let's highlight this last one. So we still have some examples to go. One of them is going to use a graph, one of them is going to use an equation, but for the vertex, I need you guys to realize there's going to be an x and a y. An x and a y. So let's go see what's going on. And this one, kiddos, I have given you a graph. I didn't make you find it. I gave it to you. Okay? Let me go ahead and zoom in on the graph because it's kind of small. Please go ahead and draw it with the important pieces of information. Meaning, you need to make sure to graph the vertex. What is the vertex? It's not the
Middle.
It's 2, 1, 2.
Well, the x-axis is going to be a little bit below, and the y-axis is going to be on the left a
No,
little.
I meant like on the paper, like, because we did the concavity, y-intercept, axis of symmetry.
Right,
vertex,
and so now we're writing graphically, and then the directions, and then this graph, okay? So just keep going down in your notes, good job. We're trying to find the axis of symmetry and vertex from a graph, so we can see the parabola. But we need to figure out from the graph, can we identify these two important pieces? Who are they? Where are they? What are they? Okay? In order to make this graph, you guys have to know a few things. What point are you making the vertex? Say a little bit louder. What was the point? Good. You can't make a good picture if you don't know where to put the vertex. So you guys already figured out the first answer to the question. To make the parabola, you need to know his vertex, and then you need to know his concave up, right? So the point for the vertex, that's the answer to letter B. You can say the vertex is 1, 2. But we're missing something. You still have to answer the axis of symmetry. Now careful, I don't just want a number, I need it written in the right way. For a vertex, I need a parentheses, a comma, an X, and a Y. For axis of symmetry, I want you guys to look, if you highlighted, if not, just look above, where you wrote axis of symmetry. And if you did your notes well, you should be able to see, what is it? X equals, right? X equals blank, and we filled in the blank with negative b over 2a. But the problem is, x equals negative b over 2a. Do we actually need to solve for it in this one? Or can we actually see the line?
You can see the line.
We can see the line. And question, kiddos, what x value does this line go through? Goes through 1. So we just have to say x equals 1 and say, haha, we're done, right?
Good.
Yeah, if you have a graph, you just need to be able to learn how to look at it and how to pull out what you need.
Homework is gonna have the graph.
For the first couple. For the first couple. This is when you're solving with the graph. Does that make sense?
Yeah.
Okay. Now, we're also going to have equations. So here's part 2. But the nice thing is, same directions. Find the axis of symmetry and find the vertex. But can I show you guys before we change the slide how we could use the formula? What was the formula you guys were all trying to tell me for x? X equals negative b over
2a.
2a. Now, look at the formula that's down below. And I want you guys to think for just a second, looking at the very top of your notes, didn't we write a squared, ax squared plus bx plus c? Who is a and who is b? But pause. Alan, what's your question, buddy? Sorry.
Go to version.
Wait until we finish this example, okay? Who is your b according to,
6.
yeah. Because it is in, ready? Ax squared plus bx plus c. Who's in the b spot?
6.
But wait,
Negative 6.
why do we have to make sure that we say b is negative 6?
Because when it's divided by 2 times 3.
The formula shows a plus, and since there's a minus, we have to keep that negative with the 6. So b is negative 6, and who's a?
3.
Positive 3.
So would it be positive 6?
Sorry guys, one of the spinners is making noise and I just can't handle it. So we're just going to put all the spinners down right now. And we're going to put it in a pocket, put it away, no more spinners. Not for today. Not outlawing them all. They're making noise. Okay, so then we go ahead and plug in, and you guys already told me B is,
6.
pause, B is negative 6 because there was a minus. When we plug in a negative, don't we need another negative for the formula? So negative 6, it's going to become a positive. So I'm plugging in. From this, we were able to say A is 3, B is negative 6, and then we're plugging into the A spot and we're plugging into the B spot. Who is B? Negative 6. Who is A? 3, but we need to simplify.
I'm confused. Is that B or 6?
B is negative 6.
B is 6.
So how do
A
you
is 3, because if we look at the beginning of our notes, we're looking at a quadratic as ax squared plus bx plus c. So we're using that pattern, that formula to help us out. Jay, go ahead.
How do you find the y? The vertex.
Oh, good question. Hold on. Pause. But real quick, we're just trying to finish the formula. So, how do we simplify from right here? This is the formula. Angel, look at your axis of symmetry. Negative b over 2 times a. It's a formula to memorize, like the area of a rectangle is base times height or length times width. That's something you guys memorized a long time ago. This is something to memorize. Okay, so we need to go ahead and simplify. What's a negative times a negative? Positive. And what's 2 times 3? And what's 6 over 6?
1.
You guys see how it gets you to the same place?
Yeah.
Without needing a graph? Why is that good? If you're asked a question, find the axis of symmetry. Do you really want to make a table and a graph if you can just learn a formula to plug in?
Yes.
Doesn't this sound faster than a table and a graph? I think so too. Now, let's go ahead and look at one algebra example. Let's look at one algebra example. All right, Jim. One algebra example. We want to find the axis of symmetry in the vertex. Could we make a table, graph it, then look at it? Yeah. But could we use the formula tricks to try to do it faster?
Yes.
Yeah. So as you guys are writing it down, when you write down axis of symmetry, you should look up in your notes at the formula for axis of symmetry.
That's always going to be fun.
Symmetry in the vertex of the same.
Same x, but the vertex also needs a y. We'll see here how to get it. And Jay, that was your question, so we're going to answer it. Because we're going to get the x, use the x, and need a y. You'll see what I do. Alan,
Wanna go?
now you may quickly.
To yourself.
Thanks, bud. I appreciate it. What formula did you guys, if you needed to remember, maybe some of you already have it memorized, what formula are we going to use for axis of symmetry?
Negative b over 2a.
And for the vertex, we still use x equals negative b over 2a. But we don't just need an x, we also need a y. So we'll figure that out. But first of all, axis of symmetry. If we look at this problem, did you guys write it down?
Yes.
Yeah.
Who is a?
2.
2.
If you need to, you can write ax squared plus bx plus c. You see how the c has a plus in the formula, but the 1 has a minus?
Yeah.
Who is c?
1.
Good. C is negative 1, right?
Yeah.
I know, just pretend it's there. C is negative 1. But that's not what we're asking. We're asking for who is A. And the answer is 2. And who is B? And the answer is 8. So we're going to go ahead and say, okay, cool. We have A is 2. B is 8. It's time to plug in, Chun, for our axis of symmetry. If you guys want, you might want to shorten axis of symmetry just a little bit. Yeah, you could do that. AOS, I guess that works. Okay, my formula says negative who?
Negative 8 over
No. Negative who? B. And who is B? Okay, I was just doing all the steps. Over 2 times who?
4.
Good. So we need, don't forget your x equals. We need our x equals. Then we need to simplify. So then we can go ahead and say x equals, that's negative 8. PEMDAS says do that multiplication, and 8 over 4 is negative 2.
Wait, where did the ice negative b from?
Plug it in. To the B spot. Plug it in to the A spot.
Oh,
Do we have our axis of symmetry? The answer is yes.
yes.
Without a graph, awesome.
What if you
I didn't
have
name
like
2.
We'll see more examples in a
I
second.
wasn't paying attention.
Josh.
Okay, these are shot down.
Letter B. Alright, hold on. This is what we haven't really done yet. The vertex. We need it to be a point. Does anybody know anything we can plug in right now? Diego. Not 0. Not 0. Look back at your notes. Vertex, we need an x and a y, and the x comes from negative 2. You're thinking about the y-intercept. That's a different point. Look up above. Y-intercept is a different point. Don't plug in 0. Wait, pause. We have an x, right?
Plug in 0 from x and find the y, right?
No, don't plug in 0. You're thinking y-intercept, separate points. Sometimes they're the same, usually not. We have -2 as an x. The question that we're all kind of thinking is, how do we fill in to finish and be done? We need a y. We have an x. We need a y. And we have an x. We're going to solve. Look at your notes. Didn't I say solve for x? Plug in to the equation to solve for y. I'll go back to remind you guys because some of you aren't looking in your notes.
Yeah.
Solve for x using the formula. Solve for y by plugging the x in. Does that make sense? Like a table. You have an x. Go find the y. So plug in -2. Plug in -2. To who? To the function. Technically, it would be this function notation thing. I'm not sure if you guys know. Where did I get this pattern?
The formula.
The formula. Who is missing from the formula? X. Who do I know about x? Or what do I know? Exactly. Now, PEMDAS, hold on careful. Some of you guys did this. Let's double check, Jay, that we simplified correctly. PEMDAS tells me to square first, right? What's -2 times -2?
Oh, I did that wrong.
Wait.
4, right?
That's 8.
It is.
Negative
I
16.
was wrong.
Now, PEMDAS says multiply, so 2 times 4 is 8. What's 8 times -2? We can multiply again.
Minus 9.
Then PEMDAS says add or subtract left to right. Good. 8 minus 16, -8 minus 1 is -9. Who is that? What is that? And what am I going to do with that y?
That's easy.
Now,
I go back.
pause and think. Has this parabola moved a lot? Ax squared starts at 0, 0. Didn't the x go left 2, and then didn't it go down 9?
Yeah.
This parabola's like way down here somewhere. Tomorrow we'll learn how to make a nice graph since he has been moved all over. But for today, we have found how to find the axis of symmetry, how to find the the axis of symmetry of the parabola, how to find the vertex from a graph and from an equation. Now I'm going to go ahead and quickly go over homework questions since we had just a few, and then people in the front, we're going to keep on doing a few more examples. So people in the back that are allowed to move in the back, you can go now. If you want, turn in your homework to me, young son. If you're going back there, you have no more homework questions. If you see Alan, tell him to get back here, ASAP.
Yes.
Turn in your homework. Okay, the rest of you guys, let's go over homework questions real fast, okay? Then we have 2 more examples to make sure we've got it.
I'm sitting. Can I sit in your
chair. I just sit in your chair.
Just pull the desk back around. We don't want someone to have the chair and someone not to. Just pull the desk around, Jordan, from back there. There you go.
Rock.
Aiden and Caleb, why are we talking? All right, let's come on back. You guys had questions on, I believe, number 10,
Yes.
and then numbers 43 and 44.
Yeah.
We're going to work backwards today. All right, kiddos, numbers 43 and 44. Diego, you're allowed to move to the back right now. If you think you understand today's section, you can start doing your homework. If you're going to do that, do so quickly. If you're going to stay up in the front, do so quietly. All right. Come. Okay, here we go. What are the directions in numbers 43 and 44? Evaluate by plugging in. Okay, evaluate by plugging in. We have A, we have B. You guys notice this is kind of what we're doing today, right? Yeah. Okay, so if we know B is -3, we should put that in the B spot, which if it helps you guys put little parentheses around the variables. It helps. Because then you say the negative is outside the B. Then I put in the B over. What else is outside of the B in the bottom? Well, sorry, what's outside of the A in the bottom? You guys looking at the problem? I know my parentheses are kind of wide, but what was down there next to the A? 2. So we're going to have 2 times who? Well, who's A? 4. Plug it in, plug it in. Negative times negative is a positive, so we have positive 3 over 8. Dun, 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 dun. Okay?
Wow.
Exactly.
Wait, why is it positive?
A negative times a negative is a positive. Now number 44, Caleb and Alan, focus. Number 44, we have to plug in a lot of things, right? We have to plug into A, plug into B, plug into A, plug into B. So then what do we plug into? Jay and Jordan, you can show each other, but just don't be talking out loud, okay? So for A, we can plug in 4 minus, B is negative 3. Plug in A, plug in B. On the bottom, you can plug in 3 times A, which is 3 times 4, plus B, which is negative 3. Now guys, there's a lot going on down there, right? I'm going to come up on here in the board real quick just so you can see it a little bit better. Tyler? Or just take your stuff and you can help this one. Thanks, buddy. Things behind my back, I don't respond well. So I have 4 minus negative 3. On the bottom, I have 3 times 4 plus, and I have negative 3. How does PEMDAS tell me to deal with this? There's a lot. This is number 44 in your homework. How does PEMDAS tell me to deal with that?
You have
Distribute it.
some parentheses.
Parentheses, is there anything to do inside them?
You can.
Just numbers. But I do see multiplication, don't you?
Yes.
Where's their multiplication, Rob?
The negatives have
Okay, so minus and negative, what can we change that to be?
Plus.
Plus 3. And the bottom?
Would be
12.
plus.
Wouldn't that be minus 3?
Negative.
Then PEMDAS says grouping symbols, do the top, do the bottom. So what's going on up top?
7 and 9.
7. And what's going, careful. Oh, no, you're right, 7, 9. So that's 43 and that's 44.
So pretty much just-
You deserve to. Okay, go ahead. Thanks, Aiden. Next time you look out for your friends. So that's 43, 44, and then I think, John, you had a question on 10. Do you still have that question, bud, or are you okay?
No, I'm fine.
Okay.
You can go over it,
Well, if you're okay, you were the only one I think that specified that.
Okay.
Kiddos, go ahead and turn in your homework to me right now. And as we do so in your notes, I want you guys to look at or to write down a couple more examples of today's lesson, okay?
Miss D, can
He
you
said, I want to go with
actually?
Bye, Miss Dewick.
It's in class instructions.
All right,
No,
notes open.
attention.
He has a baseball game.
Oh, home babe, Josh.
Okay, Rob, in your notes, let's do 2 more examples real quick of today's
Wait,
lesson.
I need a pass.
Oh,
Oh.
I already gave it to him.
Any more? 7.
No, this is.
So you drink that water fast.
All right, so let's go ahead and write down 2 more examples real quick. You guys are doing great up here. 2 more, and then we'll have it mastered for that homework tonight. I know.
Here we go, Bubble.
Thank you, thank you. Okay, writing down 2 more examples. Just to show that we understand.
We do something similar to this.
Now, if I can find my eraser, that keep something open on me. Alright, as you guys are writing down the 2 examples, you can even write them next to each other. We're going to work down in our work.
Can we go up on the board and do it?
No.
Today I'm not sure we have time, but maybe another day we might. Because I think we
6
get things
minutes
done a
left.
lot faster in the way that we're doing this now. Will you have them written down, both of them?
Yes.
Okay. I'm going to remind you of the two formulas we're supposed to be using, okay? That way when I talk about them, you can look up. They are in your notes, but they might be on a different page than we're working on. Axis of symmetry, we're using the formula negative b over 2a.
Is this 1 or 2?
For the vertex, we're using these formulas whenever we see these words.
Are we number 1 now?
Yeah. The vertex, we're going to use x equals negative b all over 2a. We're going to plug in to y, and then we're going to answer with the x and the y. Don't worry, we're going to do 2 examples. I just want you to see on the board what we're doing. So, for number 1. Guys in the back. Help each other as quietly as possible. So, for number 1, when we go to find letter A, the axis of symmetry, we need to plug into x equals negative b over 2a, but we have to go ask ourselves who is a and who is b. I put little parentheses around to say that we need to go find them. Who's already figured out who a is from the top? Rob, what do you think? Ava, do you know who a is? Yeah, good. A is 3. So if you think about ax squared.
Yeah.
Caleb, do you know who b is?
Yeah, 2.
Good.
Negative 2.
Careful. Does that make sense, Caleb, how it's a negative? How it's a negative 2 instead? Because look, it should be addition, and since it's not, we say b is a negative 2. Does that make sense?
Yes.
Now, c is missing, but we don't need him. But who would c be?
So would you put C or no?
C would be 0. But we don't need C in the formula, so we're not going to stress. But C would have been 0 since he's missing. Just to make sure you grab a seat as quickly as possible. So, you guys already told me who A and B is. Let's go ahead and plug in. Negative, who goes in the B spot? That was yours, Caleb.
Yeah.
What goes in the B spot?
Oh, 2. Negative 2.
Negative 2. Good job. And then what goes in the A spot?
3, yeah.
Just the number. Just the number. So just 3.
So you say like there's no variable?
Yeah, no variable. Well, I mean, there is a variable to begin with, but A is a part or a side or right next to the variable.
Would our answer be x equals whatever it is?
Yeah, now it's just our
So
job
x
to
equals
answer.
2 over 6.
Negative times a negative is a positive. 2 times 3 is 6. Wait, can we reduce that?
Yes.
1 or 3?
Good. Axis of symmetry, x equals a number, and we're done.
This is easy.
Now wait, what have we not found yet?
The vertex.
So you take the test, son.
Okay, vertex, here we go. Rob, make sure you're focused. Here we go. Letter B. How do we find the vertex, though? What does the vertex answer look like?
X, oh,
An
x,
X
y.
and a
So you gotta
Y.
plug it
Okay,
in.
an x and a y. So, our end goal is to have at the bottom of this, to have the x being 1/3. But we also need the y. How do we find the y?
Plug it in.
Plug it in. So we can say after x means y at the top. 3 times, what am I leaving off when I write this down?
Your x.
I'm leaving
So
the
you add
x's
1/3 in
off
there.
so we can put the 1/3 in.
Wouldn't it be x or 3?
It's not super pretty, and my 1/3 got all weird and I don't even know why. But I'm putting the x I found into the x spot of the equation. Now it's going to be a little harder than the other one that we did, but PEMDAS still says do the exponent first. So 1/3 times 1/3 is
2 things.
no times 1/3 times 1/3.
Wouldn't it be 2/3 because you put 2 over 1?
I'll help. Times 1/3. What's 1 times 1?
2.
1 times
Oh.
1. What's 3 times 3?
Not. Oh. I was reading.
So 1 times 1 is 1, 3 times 3 is 9. It's okay, it happens. And we still have 2 times 1/3.
Kids, it's Friday.
Vivea was mentioning the other day when we have whole numbers and we're multiplying, we put them over 1. So, does anybody know what 3 over 9 becomes?
Oh,
1
3.
over 3.
1 over 3.
Yeah.
Remember, 1 over 3. And then we have 2 over 3. Oh, hey, that's nice. They're common denominators. What's 1/3 minus 2/3?
1.
-1.
Careful. Negative.
1.
Because 2/3 is
Hey,
bigger, right?
Get off of me.
So negative 1/3 is what we need to put into our y value.
Smart.
Otherwise, I thought like.
That's why I'm trying
Nope, when we subtract, we do 1 minus 2 is negative 1. And then remember, think of it as 1 apple plus 1 apple is 2 apples. 1/3 minus 2/3 is negative 1/3. We keep it the same. That's our y value. So I multiplied the 2 times the 1 and the 1 times the 2. No, it's okay. So I'm doing PEMDAS. 3/9 is 1/3, 2/3 is 2/3, and then I put them together. Kiddos.
0.4.
No, see, there's sometimes different.
21%.
Kiddos in the front, you can go ahead and take a picture of your homework if you want. Keep your notes close when you do your homework tonight and this weekend.
I like this.
Okay.
I like this.
Keep your notes close. But we did a good job today. We got an extra example done,
Yeah, we're out.
and we got to see. It's a good day.
Happy Friday.
All right. Happy Friday, kids. Have a great weekend.
Happy Black Friday.
Very long. Oh, it feels good to have my shoes. Oh, that's where.
Does that make sense?
So the actual.
Is the line that goes straight through the middle.
That's so in the water. What grade do you have?
The vertex is that way, right?
December to now.
Hey, when you guys are in the back like that, can you make sure to turn around your seats?
Yeah.
Thanks. Thanks, guys. We appreciate it.
I go there.
Oh, she got it for you. I was gonna say. Thanks.
Did you put it into these things way or not yet?
Don't worry about it. I'll put them all.